Hello everyone, welcome you all to AI Ki Pathshala. Today is the second session of recursion in Python. In the last session, we have discussed one question and we have studied about the mathematics behind the recursion, that is the PMI, Principle of Mathematical Induction. I suppose it is all clear to you and the video is also uploaded. Those of you who are watching my recorded session, I will request you to see my previous videos of recursion, the first video of my recursion. Thereafter, you can come to this video. That will help you to grasp the concept in a very clear manner. So now let's go. I am going to share you my screen and we will move ahead. So is my screen visible to all of you? And is my audio clear to you? Are you getting my audio? Guys?
Yeah.
Okay, fine. So let's first. So last time we have discussed about the PMI in details. And after that, we have discussed one question about the factorial, how we will calculate the factorial. So this is the question which we have discussed last time. So just I'm making a little change in this question. What I'm going to do, just instead of this, see here, this is the code for the factorial. What I'm going to write, here I am writing return n into factorial of n minus 1. This is the function call. So I am writing this inside one variable called a small output. The output which I am getting in between the final output and the in between the final output and the initial output, that I am saving it inside this variable called a small output. This, why I am doing this? This is for the sake of making the things more understandable for you. So now onward, whatever the middle output will be, I will be saving that in this variable called a small output. And this is, and here what, instead of this thing, factorial n minus 1, I will be writing this small output. Both are same, there is no difference in it, I suppose. Fine. Let's call, you will get the same output. So I suppose we all are clear till here. Now, let's understand the second question. Here, I want to calculate the sum of first n natural number. So, for calculating the sum of first natural number, what I need to do? For calculating the sum of first n natural number, what first thing that I have to do? I have to take the base case. Inside the what we have studied in PMI, there are basically 3 steps inside the PMI. So the first step was to take the base case. For calculating the sum of first n natural number, my base case will be either 0 or 1. So what it means to calculate the sum of first n natural number? That means, and I do not want to, I know that the sum of first n natural number is, sum of first n natural number is n into n plus 1 by 2. This is the formula. But I don't want to calculate the sum with the help of this formula. I want to calculate the sum with the help of recursion, by using the recursion. So this is my question. Now see what means, let's say 1, 2, 3, 4 and 5. This is my first n natural number and I want to calculate the sum of this first n natural number. So value of n is 1, 2, 3, 4, 5. In this case, when I want to calculate the sum of first 5 natural number. So what is my base case? Base case is the value of the smallest possible value I will usually take as a base case. So here my base case can be 0 or 1. In case of 0, what it means? There is no natural number present in it. And in case of 1, the smallest natural number is 1. So let's take the base case as 0 here. If I take the base case as 0, then we will see summation of 0 is what? 0. If there is no natural number present in my list of natural number, the summation of 0 is 0. Nothing I will get. So this will be my base case. I am going to consider this as my base case. After that, after the base case, there comes the assumption or the hypothesis that I am going to take. So summation of n can be written as n plus summation of n minus 1. I can write summation of n as n plus summation of n minus 1. How this is? How I have written this? See, if I have taken 5 natural number and I want to first 5 natural number and I want to take the sum of this 5 natural number, what will happen? This is my 5. So I am taking summation of, see this, summation of n minus 1. So what is the summation of n minus 1? Means summation of first 4 natural number. So I am summing first 4 natural number. This is n minus 1. N minus 1 is 5 minus 1, 4. And in that I am adding this n. Means I am adding the last number. So this is my base case and this is my assumption. The middle thing, I am assuming that this sum of first 0 natural number is this thing and sum of my n minus 1 natural number is summation of n minus 1. This is my assumption. I don't have to understand this thing in very detail, because whatever be your assumption state, you do not try to dig deep into it, because take it as your assumption, because this I am assuming and I am using this to prove my final outcome, final output. And this is my final output. This is my task 2. Final thing, task 2 that I want to take. What is my final task? That I want to print this sum of first natural number. So it consists of 3 steps. Just remember, my first step is the considering the base case, which I have taken here as 0 is my base case. I can even take 1 as my base case, but I have taken here as a 0. Second step is to take the assumption that what I am telling, if this thing is true for 0, so it must be true for n minus 1. If summation of 0 is true, then this thing is true for summation of n minus 1. So this is my assumption, or you can say hypothesis. This is my assumption, or this is my hypothesis. And by using these 2 things, I want to prove my final outcome, because if this is true and if this is true, this must be true. What is my final thing? That I want to calculate the summation of first n natural number. For that, I am using this. I am considering the first the summation of first n minus 1 natural number, and in that I am adding this n value. Hope this mathematics is clear to you, all of you. Please tell me yes or no.
Sir.
Ruchi?
I'm not able to get this assumption part.
Okay.
Why
So
we have taken n and minus 1? Is it a formula to calculate n?
see, permute what we have discussed. If you go through the lecture of the last lecture of PMI, it says us three things. My first thing is the base case.
Yeah.
This is the first thing that the PMI
Yeah.
says. Okay.
Okay.
Second thing, and this is my task one. This is my task one that I have to do.
Okay.
Second step of PMI says, if in case of what second step is my assumption step. Assumption step. Let's say there is some function f0 and it is true for f0 or f1. Let's say f0 or f1, it is true for the base case. My base case is 0 or 1. So I'm assuming that it must be true for f of k. If it is true for the base case, this is my base case. This is true for 0 or 1. And here, let's say there is one function and that function is true for the base case 0 or 1. So if it's true for or both, if it is true for 0 or 1, so it must be true for f of k. This function must be true for some number k. And this is my assumption. I need not to prove this. I do not need to prove this statement because I'm assuming it. Since I have assumed it, this is my assumption state or also called hypothesis. Same thing is called hypothesis. Hypothesis. And by using my base case and my hypothesis, I am proving that I have to prove that f of k plus 1 is true. Is true. Is it fine for you? Or f of k minus 1 is true?
Yeah.
Is it fine for you? So,
Yeah.
whatever concept I have discussed in PMI, Principle of Mathematical Induction, the crux is these three steps that you have to follow. Well, whenever you will be solving the recursion problem, you have to keep in mind these three concepts. And one most important thing, and the warning for you is that why people mostly get confused in recursion, because they actually fall in the trap of this second step, this assumption part, because they delve deep into it and start thinking about this. So you don't need to think about this thing, this part, assumption part. Why? Because you are assuming it. You still have no proof of it. Based on your base case to be true, you are assuming that your f of k should be true. And by using these three, you are proving your output. What you need to your question, whatever your question is asking you to do, you are proving that thing f of k. And if that comes out to be true, that means your recursion is working properly. The same thing I'm using here. Now let's see here. I have given you this question. Let, let me see. I have given you this question. Calculate the sum of first and natural number using recursion. You already know the formula and everything. You can calculate it very easily, and some other ways are also there. You can calculate, but I wanted to calculate it with recursion. What it means? Let's say the value of n is equal to 5. Calculate the sum of first n natural number. If value of n is equal to 5, then what I am telling you to calculate 1, 2, 3, 4, 5. Is this clear? I am telling you to calculate the first of this 5 natural number 5 by using recursion. So now come to the first part. What is my first thing that recursion says? Consider your base case.
Okay.
So what is the base case here? Base case here can be n can be either 0 or 1. Both I can take. Only the thing is that if I am considering 0 as my base case, then in that case it will return me nothing. If I will take 1 as my base case, then it will return something that is 1. The output it return. So let's say I am considering the smallest base case that is possible as 0. Here. That's my base case, and I am taking here 0. This step is clear. Now, then comes the second step, assumption part or your hypothesis. Assumption part says, if n is equal to 0, my summation of n should be 0. This is my base case. Base case. And now, if this is true, I'm assuming summation of n minus 1 is true. This is my assumption. Just don't dig deep into it. Just understand that this is my assumption. If summation of n is true, summation of
we need to take assumption always true.
Yes, we will take our assumption always to be true.
Okay.
And based on these two things, your base case and your assumption, you have to calculate your final output. And if it is coming out to be true, then definitely your assumption is true. And if it is not coming out to be true, definitely you are doing something wrong. This is how the PMI works.
Okay.
I request you to please go through the PMI lecture once again. Is it fine? So that first time thing is that you do not able to understand things in that deeper way. But whenever you go through the lecture again at your own pace, you will able to understand it in more deeply. Now come the third step or task 2. This is my task 1. I call this my task 1. Task 1. This is my assumption or the middle thing. And this is my task 2. What is my task 2? Task 2 is
to be proved.
To prove. What I have to prove? Summation of n is equal to summation of n minus 1 plus n.
Plus n.
This is my this is my this is my final thing. So here what is it? This is my assumption. I don't have to worry about this.
Okay.
And if you just think over it, see, what is it? To calculate the summation of n, what actually you are doing, you are considering your assumption. Your assumption is n minus 1. N minus 1 is this. Summation of n minus 1 is summation of 1 plus 2 plus 3 plus 4. And in that, what you are adding? This n. So you are getting the final thing. Is this?
Yes.
So whatever I have explained you here, I am going to write the same thing just in the form of code. Fine. Okay. So
I just want to ask one more thing, that yes. Is it necessary to take the smallest base number will be 0?
It is not necessary, but it is if you take it, you have to see it varies upon the questions. See, you have to, if you do not consider your base case, you have to limit your recursion somewhere. If you do not consider it, it will keep on going till infinity. So you have to consider one base case, and usually that base case comes out to be the smallest possible thing. But if you do not consider that, you can, it is not mandatory to consider it to be the smallest thing that you are going to do, but it is convenient to, if you do that, it is easy for you to calculate your further things. That's why we take smallest possible thing as the base. I'm going to explain you this thing again in the coming questions. You will understand why I was why we were taking the smallest thing. So let me clear this thing, and let me write the same code for you, so that whatever we have discussed right now, I'm going to just convert this in the form of code. Very easy code is there, so you will understand it. So let's write, this is the function sum of n, sum of n. I'm calculating the sum of first n natural number. This is my function definition. Now, if n is equal to 0, 0, return 0. Because if n is equal to 0, my function should return 0. Why my function should return 0? If n is equal to 0, the sum will always be 0. Is it fine that I have discussed? Ruchi, are you getting
Yeah.
this? If
Yes.
my n is equal to 0, my
Then
sum will
you.
be 0. That's why I am returning 0.
Yeah.
So this is clear.
Yes.
Now, I am calculating a small output, that is output that I am getting in middle between the final output and between the base value. Between the final output and between the base value, whatever output I am getting, that I am taking that inside one variable called small output. Is it fine? Small output. So for a small output, what I am doing, this is my, I suppose this is my assumption step. This is my assumption. Now I am writing also here so that it will be more clear to you. See, sorry, this is my base case. Fine. If it is true for n is equal to 0, it must be true for n minus 1. Summation of n, sorry, sum of n minus 1. So this is my assumption step. This is my assumption step, assumption step, or also called induction hypothesis. Induction hypothesis. Hypothesis. Just understand it in a mathematical way. Now I am done with it. Don't think over it much. Just understand this. Now, what will be my output? My output will be my small output plus n. This is my induction step. It is, this step is called induction step. The 3 step or task 2 induction step or task 2. This is my base case or task 1. Now, what you want? Just return output. Return output. Return output. Please tell me, is anything that you do not understood in this code? Mr. Misra sir, Miss Ruchi, both of you, please help.
After a return output, do we need to write something else also?
No, no, we are returning the output simply. Whatever output I am getting, I am returning it to my function call. Nothing. Thereafter, you.
What about the last one that we discussed?
Which last one?
The last step. Acha. Okay, task 2 will be the last step, na?
Yes, yes. Only three things is the base case or task one. This is called assumption step, or this is also called induction hypothesis. And this is
Yeah.
my induction step or task two. So
Okay.
this is the three step.
Okay, thank you.
And I am returning the final output. I need to return this. I have run this. Now I have to call it function call.
Hmm.
So let's give me any number.
5.
5.
Yeah.
See, my output is 15. That sum of the first 5 natural number is 5. Is it fine?
Yeah.
If you can try something else, let's see 10, you will get different thing. Hope this is clear to you. Mr. Misra sir, is this clear to you?
Yes, yes, yes.
Fine. So now let me come to the next question.
The wire is not defined.
What?
I'm getting an error.
So you can ping me your code in my chat box, and or what else we can do?
Might be my indentation is not correct.
Fine. You can check it out, or after the class, after we end this session, you can discuss with me. We can have a one-to-one discussion. I will resolve
Okay.
it. Now, this question. Let me explain you first this what this question is and what I have to do in this. So see, what I want here, I want to do two things here. What two things? Let me tell you. Print first and natural number. Okay. So first we have to print from 1 to n. N, oh here, it is a mistake. It is not n. This is 1. I will correct it. And my second thing is print from n to 1. So let's say the value of n is, let's say 5. So first question is print 1, 2, 3, 4, 5. This is my first part. This is my first question. And my second question is 5, 4, 3, 2, 1. So this is 1 to n, print 1 to n, and then print n to 1. And you have to do this by using recursion. You have to do this same question by using recursion. So hope you understood this question.
Yes.
Fine. So let me first correct this so that it is n2, it is 1. Fine. Now let's try to understand something that I would like to explain to you first. Thereafter, I will going to explain you. Let's take the value of n to be, let's say value of n to be n is equal to, let's say 4. So what you have to do? What you have to do? So P This is the first thing. It will call P3. This will call P2. It will call P1. And finally, it should return. It will call P0. So I will explain you maybe after writing a code. That would be a better idea for. In that way, you will understand it. So let me first write it. And first, let's try to understand the base case. What is my base case here? So when I'm trying to print 1 to n, first take this thing. First consider 1 to n. What will be my base case? My base case can be 1 to 0. It can be 1 to 0, 1 to 0, or 1 to 1. Fine. If I consider the base case to be 1 to 0, that means or if I consider the base case to be 1 to 1, I have to do nothing in this. I need to do nothing here. Because in 1 to 0 or in 1 to 1, there is no number in between 0 to 1. In 1 to 1, I have to simply print this, only this thing. This one part is getting printed or one part. So actually, I don't have to do anything in this. If I consider this to be my base case. So I'm considering my base case to be 1 to 0 or 0 to 1. Is it fine? So if the value of n is equal to 0, what it means? If the value of print the first n natural number and I am taking n is equal to, let's say, 0. I am considering my base case is n is equal to 0. If n is equal to 0, then you have to print nothing. Because what you have to print? You have to print the first n natural number. And the first n natural number, n doesn't comes inside this first n natural number. So you need not to print anything if you are taking this as your base case. If you say, let's say if you take n is equal to 1 as your base case, then in that case, what you need to do? You have to print this n. You have to print this n in that case. But I am taking here n is equal to 0 as my base case. And considering this, I am going to solve this question. Is it fine for you? No.
What will happen if we take 2 as our base case?
What will happen if you take 2 as a base case? So you can do that and check the output, what you will get. If you take 2 is n is equal to 2 as your base case here in this case, so you have to provide the condition accordingly. And if you are using the condition that I am going to use, you will start printing from 2. So you are skipping the number to print which comes before 2. say I have asked you to print number from 1 to 5. 1 to 5. 1, 2, 3, 4, 5. And you are considering 2 as your base case. So if you are taking 2 and you are returning 2, then you are printing this thing, this thing, this thing, this thing. If I wrote this, and you are skipping this one, this one is never printed. So either you have to write the case in such a way that this one should also be printed. Otherwise, your output will not come. Fine.
Fine.
So let me first write it, and then I am going to explain something more in this. So you have understood the base case here. What is the base case? So let's sum underscore n. So this time you have to tell me, then I will going to write anything. I will not tell you anything. I will not write unless you will not tell me the answer. Tell me, what is my base case?
0.
Okay, so what I should write? If
If
n
n is equals to 0.
is equal to 0, what I
Column.
what it
Return
should
0.
return?
Return 0.
It should return 0.
Yeah.
Return 0. Or return 0 or return nothing. It has to return nothing, because I do not want to print 0.
Okay.
First and natural number. I do not want to return anything. If n is my 0, so I don't want to return anything. I don't want to, I want to do nothing here.
Okay.
Fine. That's why I
Fine.
will not write this 0. I will simply write return. Simply what it means, it is returning. That is, it is stopping there. It has reached its base case and it has stopped. It has stopped the recursion there. It will
Okay.
not go further. And it is returning me nothing, but it is returning its previous call the function which has called before it. You will understand this. Let's first write it. So we have resolved the base case issue. Fine. This base
Fine.
case we have already resolved. This base case BC I am writing here, or base case we have resolved. Now comes the hypothesis part.
Small.
Small output, or you can also call it hypothesis. So if my base case is true, we have already explained it, what it should be. Oh, sorry, it is,
Some
oh
under.
sorry, what I am doing this, why I am writing this sum underscore n. I have to write it print underscore 1 to n. Oh, I was doing a blunder mistake. Actually, I have not seen it. So when I am going to write this a small output, then I saw that what I am doing. So see, so this I have to print from 1 to n, and if I want to print the same thing, n is equal to 0, I want to return nothing. Fine. So this thing is taken care of base case. Now comes the small output. So what is my small output?
And print underscore 1.
Print underscore sorry,
1
underscore 1 to
2 underscore n
n
bracket n minus 1.
n minus 1. So here we are taking care of my induction step.
Okay.
And if if this is true, if this is true,
Yeah.
Then what is my final thing output? I want to print.
Output is equals to
If I simply write print n, is it fine? Print n. If we have taken care of my this hypothesis induction, this is induction hypothesis, this is induction hypothesis, induction
mm,
hypothesis. So we have taken care of this base case, we
mm,
have taken care of this induction hypothesis, and then
mm.
what we have to take care, what is the last thing? If we have printed from,
Induction step.
if we have I have printed till n minus 1, then
Mm,
what is the last thing that I have to do? Print n.
mm,
If this is true for 0 and this is true for n minus 1, then this is true for n also, that is n.
yeah.
So n, here I want to return, or if I do not even type return, it will be fine, but let's return it. And this thing you want to return, you can also write it as output is equal to print n, and thereafter you will return this thing. It is both is same. So have you understood this thing? N is
No.
equal to 0 taken care, n minus 1 is taken care of, and now this n. If you have printed
Why we
from,
have not done small output plus n here?
because here the context of the question has changed. There you
O-
want to find the sum. Here you are not want, here you do not want to find sum. Here simply you want to print.
Okay.
Even if you do not, this, see, this small output is just for your understanding. It has nothing to do. If you even remove this, it will be fine. Let's remove it so that you don't get confused. Now see, this is my base case. And
Mm,
here, why I am not doing this? Because there in the last question, we have to sum. That's why I was writing that. But here I do not need to sum. Here I have to
okay.
print. So I am taking this base case. Thereafter, I am taking this as n minus. I am considering that it is true for n minus 1. And if it is true for n minus 1, it must be true for
Then it should be 2 for n.
n. Fine.
Okay. Fine.
And this is also called the extended form of PMI. What the extended form of PMI says, there is one concept called extended form of PMI. Now let me explain you that thing called extended
Mm,
form of PMI. PMI. What extended form of PMI says? First thing that we have discussed, that base case is true. Let's say base case f is equal to 0 or f is equal to 1 is true.
mm,
Then I have assumed that f of k should be true. And then
mm,
I need to prove f of k plus 1. This is my normal thing. Now the extended form of PMI says,
mm,
if f is equal to 0 or base case, or f is equal to 1 is true,
mm, mm,
then whatever comes in between the base case and my f of n should be true. That means f of 0, f of 1, f of 2, f of 3, f of 4, everything is true. And based on that, I am calculating my f of n or f of k plus 1, whatever you call. So this is the extended form of PMI. This says that not only I'm considering one case, I'm considering all the cases in between the base case and my output, final case to be true. This is the extended form of PMI, and we will be going to use this thing later. So now I have printed this and this has returned. Now let's run it and check. Thereafter, I'm going to explain you the code, this code in a more print 1 to n. And which number you want to print?
7.
7. See, 1 to 7 gets printed. Now, this is the thing that you have used recursion to solve this question. Now, let's go deeper into this code and let's try to understood how this code is actually working. So now I'm going to explain you that thing. So be focused here. Mr. Shankar sir. Mr. Shankar sir.
Yes.
Are you understanding these things?
Yes.
Fine. So, sir, I am going to explain you now this code. I am putting this print n minus 1 for the sake of writing. Print underscore 1 to n is equal to p. Let's say I am writing it here as p. Fine. So that it will be easy for me to write.
Are
See.
you explaining the same code?
Say.
Are you explaining the same code, na?
Yes, this code, this thing that we
Okay.
have run. I'm explaining you this thing. Same code.
Oh, yeah, yeah.
Print
Got it.
underscore 1 to n is a larger thing, so I have to write it again and again. That's why I'm just naming this thing as p, small p,
Yeah, got
just
it.
for the sake of writing, so that I do not need to write this long statement again and again, because I have to write it several times. So whenever I write p, so understand this, I am writing print underscore 1 to n. Is it fine? So
Fine.
now, what you have done here, what actually you have done, you have called this function p7. Fine. And you are getting 1, 2, 3. So let's consider a smaller number for the sake of understanding. I am taking that number as 5. Let's say p5. So if you take v5, what output you will get? 1, 2,
2, 3,
3,
4,
4,
5.
5. So how you are getting this output? With this code, I am going to explain you this. See now, I have written p5 here. Now, here it is when I call this function, the control comes here. It will check if n is equal to 0. Is 5 is equal to 0? Tell me.
No, false.
False. Ruchi, getting this thing?
Yeah.
So 5 is not equal to 0. That means it will not go inside the if block. So what will happen? It will jump from here to here. Now see what this is telling. What this is telling. Print n minus 1. P n minus 1. What is n minus 1?
4.
4.
So what I will get? P4. Now, this P4 is actually a function call again. So from here, the control will jump to again here. Now, again it will check if n is equal to 0. See, I am not going below this time because I am coming here and it is recurring. Recursion is occurring here. Function is calling itself again and again. This is what recursion is all about. And I am jumping from here to here. My control is jumping here because Why control is jumping? Whenever I am coming to this step, it is again same function call. So I am getting jump to the first thing and I am not coming below. Now what is going to happen? Let's see. P4, this is a function call. It will come, it will check. Is 4 is equal to 0?
No.
So what will happen again? The control will come here. It will know. So here what will happen? It will call P3.
3 and minus 1, 3.
3. So after this is again a function call. So what it will call? It will call P2.
P3.
P2.
Acha,
P2 because n is still not 0.
Yeah.
After that, what it will call?
P1.
P1. After P1, what it will call?
0.
P0. When 0 occur, see here. This time n is, what is the value of n here?
0.
So is n is equal to 0 true or false?
True.
Now it will go inside this if block. And what this if block is telling me?
Return none.
Return none. So now it will stop. The recursion will stop here. That means it will not, further calling will not occur. The function calling will stop here. And it will return. If I simply do not give this base thing, base value here, n is equal to 0, it will keep on recurring. That means then P0 after P0, P minus 1, P minus 2, P minus 3, and we fall in the endless trap. And it will go till minus infinity. Are you getting my point?
Right.
Yeah.
So this is the purpose of the base case. So it has stopped here. And now what it is telling me to return? Return to which? To the previous function call. So it will return to previous function call. What to return? Nothing.
Nothing.
Because I am giving it nothing. I am asking it to return, but do not return anything. Just return. So it has just returned here. Now when it comes to P1, what is P1? This is returning back to P2. Now my recursion has stopped. So this print statement after this will start execution. This print end. So now when it is returning to P2, what it is telling? Print 1.
1.
Now this P2 is returning to P3. What it is doing? It is printing 2.
2.
When P3 is returning to P4, what it is doing? Printing?
Printing P3.
When P4 is returning to this, what it is telling?
4.
And finally, this P5 is what it is returning me? Finally, it is
5.
me 5. Matlab, it is returning. What it is returning? It is returning the print. This because this block has stopped working now after the base case, and it is backtracking. It is also called backtracing. Okay, it is coming backward.
Backtracking.
Just forget it. Otherwise you will get more confused. I will explain you this concept later. It is actually backtracking, na? It is coming backward. See.
Okay.
Backtracking. It is coming backward. So, and it is returning. What it is returning? It is returning to the function call of the last function call before it. So this was the last function call of P1. Before P1, the function call was P2. Before P2, the function call was P3. Before P3, the function call was P4. And before P4, the function call was P5. Fine. So it is backtracking here, and it is printing the all the values from here 1 till 5. Print it.
Can you explain this backtracking also? I mean,
Please.
after
I've used the wrong. Just forget this backtracking, because otherwise backtracking is actually, I will explain you sometime later. But you can say it is a backtracking.
no, after this P0
Yes.
till P0 is okay, then how it is printing this? I mean, because after that this calling is stopped. Okay, then
This
how it is printing this 1 2 3 4 5 7?
see, this is, I have explained you. Let's tell me. Let's explain you. So how this is occurring? See, when I have called P5, see, so it is jumping from here to here,
Right, that this is
and
understood till P0 is understood.
yes, and it is going till here. Fine.
Right, again coming back and going back. Yeah.
Going back. It is
Till
not
it is
coming.
PG till P
It
is
is
equal to
not
0
coming downward. It
and
is
is equal
not
to
coming.
0. Right.
When it reached P is equal to 0, now my base case has reached, and now it has returned. So it has returned what? Nothing.
Nothing.
So it has returned nothing to P1. This P1.
Okay.
This P1. This P1. This time, this is P1, na? P1. After P1, what is it? Print n. So it is printing 1. Then
Okay.
call P2. This is
Okay.
P2.
Okay.
After P2, I want to print it, na? That's why I
Yeah.
have written this print n here.
Yeah.
So
2.
it is printing 2. Again
Okay.
P3. After
Yes.
P3, now it is going downward, because
Okay.
now the recursion is not occurring.
Right. Right.
So this is the, in that sense, I am telling, I have told you, it is backtracking.
Okay.
Instead of
Okay.
printing from 5 to 8, it is backtracking. It is coming in the backward direction and it is printing. Is this clear to you now or not?
Yes. 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 Yes.
Is it crystal clear?
Yes.
Am I teaching you in a better way?
Yes. Yes.
Okay. So, Ruchi, have you understood this? Ruchi? Ruchi, are you getting my voice? I suppose we have lost Ruchi. Kindly confirm, Ruchi, are you getting my voice or not? There is some network issue at the Ruchi end, I suppose. So let's clear all those things. So let me tell you one joke. So what this joke is about? So this is like, there was a lady whose name was Matinda. So she was living in a New York City. So one day she was walking on a street, and a bus came, and she met an accident with the bus. So after she met an accident, her leg, her hand, and lots of bones, all of it get broken. So people there gathered and she take her to the hospital. She went to the hospital and she was like crying, "Hey God, why you have done this to me? I'm still I'm still unmarried." And by the way, Matinda was 53-year-old lady, and still she was unmarried. So she was cursing God. God, you have been very unfair to me. I want to get married, and I am still unmarried, and you have done this to me. This is not fair and all. So what happened when the doctor was trying to do all his efforts to make her health a better one? So what in the in this between, when she was cursing God, God appeared in front of her. So usually God appeared in at these
इसमें
places.
और इसकी सुनी दो। अच्छा तुम क्या वो लगाई हुई है हैं इसलिए
So
तो उधर
usually
उधर नहीं है जगह। अरे
see,
वो वाला उस पे लगाओ ना जो वो तो है उसमें तो है वहाँ पे हैं नहीं अच्छा से बैठो ना इसको।
so usually what happens that at these places like hospitals and all those things, God very often used to come. So she told me that God told me that see, okay, what you want, tell me. So I want to leave more. So God told me, okay, fine, I am giving you 100 years of life. So live your life. I have bestowed you with 100 years of life. And God get disappeared. Thereafter, what happened? This girl, recovery rate of this girl become very fast. And within 3 weeks of time, she get completely recovered. Completely. Thereafter, this insurance company, she also has a huge insurance. So all those insurance companies has paid her a lot of money, in millions and billions in billions money. So now she thought, what I will do with that money. So she remained hospitalized for the next 3 months there, and went to the cosmetic department of this cosmetic department of that hospital, and
Okay.
drew and changed her body altogether.
Okay.
So what she has done? Changed her body to altogether. So
Yeah.
she has done the plastic surgery on her face. She changed her face. She has done a lot of cosmetic activities on all her body parts. She has done a lot of small these that things, and because she has got huge amount of money. And when after 3 months she came out of the she get completely changed. Her outlook, her way of, her style, her dressing, everything got completely changed.
So
So,
you remember this black.
so after that, when she came out of the hospital and again she was walking on the road, this time what happened? A truck came and she met an accident with the truck. So this time she died, and obviously she went to heaven. There she saw the God, and she was very furious. God, you have promised me that I am bestowing you with 100 years of life. And what you have done to me? You have taken my life. So God looked at her. She said, oh, you Matinda? Oh, sorry, Matinda. I have not recognized you. It's the you. What can I do?
The concept story.
Fine. So let's discuss next question. What was my next part of this question? In the first part, I've told you to print from 1 to n. And in the second part, what I need to do, I need to print from n to 1. So most of the thing will remain same in this question. Only few things get changed. So let me copy
No, 1
this.
and 2 is same, na? 1 and 2 question. Print
This
first and natural number and print 1 to n, same, na?
this first n natural number, you have to print 1 to n of first n natural number.
Yeah, same.
And this thing, I am not talking about this thing. Actually, this is a question. This is a question, actually, and it has two parts. This question has two parts. This is part one of the question, and this is part 2 of the question. Hope it is clear now.
Yes.
This is a main question, and this main question has two sub questions. So this is my first sub question, and this is my second sub question. So now I am coming to this part. I have already done this print from 1 to n. Now I want to print from n to 1. So just I am copying this entire code and printing it here and pasting it here. And I will make a few changes here and see how the things will get changed. So now, what thing is getting here? This will remain same. This thing will remain same. My base case will remain same. Only thing is that what I was doing, let's understand this with the help of the same example that we have discussed before. See, P5 called P4 called P3 called P2 called P1, this called P0. Fine. So last time what was that? This was returning nothing to P1, and in this way this is getting printed. So what actually was printed? 1, 2, 3, 4, 5 in this way, in this order, 1 till 5. Now I want to print 5, 4, 3, 2, 1 in this order. Fine. So what I have to do now? So before the function call, before every function call, before I am calling a function, I need to print that number. Before P5, before actually I am making a function call, I need to print 5. Print 5. Print 5. Before making this function call, I want to print this. So I am print 4. Print 3. Print 2. Print 1. Fine. See, this is my base case. I am returning nothing if n is equal to 0. Now see what I am doing here. If I will, sorry, let's change it a little bit. First, what I need to change? And write print here, print n. Print n. Fine. Even if you do not write return, it is fine because you have to print it anyway. And if let's you run this, and now if you call, first I'm calling, then I will let you understand 1. Sorry, not 1. Let's write n, 2, 1. Now run it. Print underscore n underscore 2 1, and you want 5. Let's write 5. And if you run this, you are getting, see, 5 4 3 2 1. Are you getting this? See? So how this is occurring? Let's understand this. So when I have done this, when I have called P5, so it is checking. It is checking. Is n is equal to 5? Tell me. Sorry, is n is equal to 0? True or false?
False.
False.
So it is jumping from here to the next statement. What is this?
Print 5.
So it is printing 5. After it is printing 4, it is going inside this block of code. What is this?
Print n minus 1. Print 4.
So what is this? This is print 4.
4.
This is a function call.
P4.
This is a function call.
Yeah. Again, we'll go back to definition.
Again, we'll go back to it. This time it will check, is 4 is equal to 0? No. It will print 4.
Yes.
Again it will come. Again it is a function call. Go back. Then come here. Print 3. Have you understood this or not? Tell me. Ruchi?
No.
No? What you
No.
have not understood in this? Please tell me.
The whole thing.
Okay.
In this case, return will not come. Return is there. Okay. In the last.
If you can return, if you do not write return, it's fine. Because actually you are not returning anything. You just want to print it. Even in the previous case, if you
Okay.
do not want to write return, it will give you the same result. Because I hope I have told you that you should have remembered print and versus return statement. I've explained you. So here return is not necessary because you simply want to print. You do not want to return anything. Wherever you want to return, you have written it. N is equal to 0. See, Ruchi. Just take P5. Fine. What is the value of n here?
5.
So is 5 is equal to 0?
No. False.
So what will happen?
It will move to print n.
So what is print n?
5.
So what it will do?
It will print 5.
So I get 5 here.
Yeah.
I get 5 here. Fine.
Yes. Fine.
Thereafter, what will happen?
It will go to the next loop.
Not
n
loop.
minus 1.
This next statement.
Next statement n minus 1, then 5 minus 1, 4.
So
then n become 4.
So what will happen? P4.
Then n become 4.
This is a function call.
Yes.
So what will happen?
Then n become 4.
Fine. So this is P4. It become P4. I've written. And this is a function call. So the control will shift from here to again here.
To the starting.
Now P is 4 is equal to 0.
No.
So what here it will come again.
Yes.
This time what it will print?
It will print
4.
4.
Again it will come here.
Yeah.
This time what will happen?
4 minus 1.
P3.
3.
This is a function call.
Yes.
It will
Then
again,
again.
control will shift here.
Yeah.
Is 30?
Yes.
30?
No. No. No.
Then it will what? It will print 3.
It will print 3. Then again it
Thereafter
goes
again
uh,
2.
2.
This is again a function call.
Yeah.
So what will happen?
Again it will go to
Here
n is not equal to 0. Huh?
again it will print 2.
Yeah.
Then what will happen? This P1.
Yes.
This is again a function call.
Yeah.
It will come here.
Yes.
This time what will happen?
P1.
This will what will happen? 1 is not equal to 0, so it will come here.
It will print 1.
So it will print 1. Thereafter what will happen? Again it will come here. This
Yeah.
time what will happen?
1 minus 1 0.
It becomes P0.
Yes.
This is again a function call.
Yeah.
It will come here.
Yes.
This time what is the value of n?
0.
So now this case is becoming true.
Yes.
This is my base case.
Yeah.
Then it will go inside this if block.
Yes.
What this if block is telling me? Return.
None.
Yes, return none. So it will
Yes.
stop here.
Yes.
My recursion will stop here.
Yes.
And it is returning nothing.
Nothing.
So it is returning nothing. But I wanted to print 5 to 4. That's why this time what I have done before the function call, because what is
Yes.
happening, it is going inside, it is going when I reach the last function call, then after I am returning it and printing it, start printing. But
Yeah.
so that was called backtracking. We are actually backtracking. That I was
Okay.
doing in the last thing, na. But here I
Yeah.
am not doing backtracking. Here I am printing before the function call.
But in line number 25, in line number 7, you have to write print and print underscore n to underscore 1.
Mm.
What?
Isn't it?
What?
In line number 25,
Yes.
line number 7, you have written print 1 to n. Print it should be 1 n to 1.
Oh, yes, yes, yes. I was doing n to 1. Yes, yes. I was doing a mistake here.
I don't know why your output is coming like that, because I was doing the same mistake and my output was coming 5,
No.
then 1 to 3.
And okay. I have done mistake here. N to 1. Okay. So this is I suppose this is the mistake. N to 1,
Yes.
and underscore n, 2 underscore 1 and minus 1. Fine. If I run this and if I run this, now it's fine. Now it's fine. I have done the mistake there.
Yes.
Have you understood?
Yes.
So shall we move further?
Yeah.
Okay. So let's move further. The next question. So let me explain you one more question here. This time, let me explain you one more question. So what is the question? Okay, fine. Let me tell you Fibonacci. How many of you know Fibonacci number? print the, this question is print the Fibonacci number. This is my question. So let's understand what is Fibonacci number. Then we will understand something more, how we have to deal with this question. See, Fibonacci number starts from, this Fibonacci series starts from 1. If you know, it starts from 1, thereafter 2, 3, 5, 8, 13, 21. The first two number is 1 in the Fibonacci. Some people start it with 0 also. So, but this is, I am starting it with 2, because most of the places you will find this thing. Fine. So, Fibonacci series, this is a series, Fibonacci series of number starts from first 2. The first 2 value of the Fibonacci series is, first value is 1 and the second value is also 1. So, what actually is happening? After this, the third value will be the sum of the last 2 values. That means this 2 is coming out of this 1 plus 1. This 1 plus 1 is giving you this 2. This 2 plus this 3. This 2 plus 1. This 2 plus this 1, last 2 values, is giving you 3. This 3 plus 2, last 2 value, will give you 5. This is giving you 5. This 5 plus 3 is giving you 8. This 8 plus 5 is giving you 13. This 13 plus 8 is giving you 21. Hope you understood this. So, Fibonacci of n is basically Fibonacci of n minus 1 plus Fibonacci of n minus 2. It is the sum of the last 2 values. Hope you understood the Fibonacci. What is Fibonacci series? Ruchi, have you understood this Fibonacci series?
Yes.
So, the ideal way to deal with this type of problem is the iterative way, but we are studying recursion. So, we will solve this question with the help of recursion. This is a series whose first 2 values is 1. You have to always remember this. Fibonacci series starts with the first value and the second value always 1, and thereafter the subsequent values will follow this rule. Fibonacci of n is Fibonacci of n minus 1 plus, that means any value in this series you will give a, if you consider any value in this series, that value will be the sum of the last 2 values. Fine.
Yes.
Now, if we have to print the Fibonacci number, you have to simply print the Fibonacci number. So, let's first see what should be your base case. My base case is 1 here. 1 is my base case because Fibonacci always starts at 1. 5, 8, sorry, 5, 8, 13, 21. Let's write this. So, F1 is our base case. F1 gives me F1 is equal to 1. Now, let's first write code of this number, this thing, then I am going to explain you further thing. Let me write a code first. So, what I am writing, let me code first. So, print the Fibonacci number. So here, let me write here 1, 1, 2, 3, 5, 8, 13, 21, and this will goes on writing till here. Now, one very important thing. First, let's write def. Let's fib. Fib means Fibonacci, and thereafter, this is the function definition. Tell me what I will write, Ruchi. Please tell me. Are you listening, Ruchi? Mr. Misra sir, are you there?
Yes, yes.
So tell me what I will write here. What is my base case?
It should be
1 is my
one.
base case.
One.
Fine.
Yeah.
What I will write if n is equal to 1.
1.
What it should return? 1.
1.
Fine, because my base case is 1 and I am
But
returning.
sometimes 0 is also Fibonacci, na?
Yes, that I have told you before. Some people consider, somewhere you will see that 0, 1 Fibonacci start from 0, 1. Okay. And in somewhere you will see it will start from 1, 1. But what I have seen in most of the places, you will see it will start from 1, 1. At some places, you will see it will start from 0, 1. So I have to take only one case. So I have taken that it starts from 1, 1. Fine.
Okay.
So there is a conflict in this. So let's not go into it. Let's take this 1, 1, that Fibonacci starts from 1, 1. You are right. What you were telling. So if I take this, then my base case is 1. I have taken 1 as my base case. And if n is equal to 1, I am returning 1. Everything is fine till here. My base case is resolved. What? Base case resolved. Fine. Now, we have talked in the last thing I have talked about the extended form of PMI. In the extended form of PMI, what I have to do, I have to assume, I have to first consider the base case. And after that, I have to assume that everything from 1 till k is true. In the extended form of PMI, I have to consider everything from 1 till k should be true. And based on that, I have to prove what? I have to prove f of k plus 1. So same concept I am using here. So let's take Fibonacci of n minus 1, Fibonacci of n minus 1 is equal to fib n minus 1. Are you agree with this? Fibonacci of n minus 1 is fib n minus 1, and Fibonacci of n minus 2 is fib n minus 2. Then my what should be my output? Output is fib n minus 1 plus fib n minus 2. This is the Fibonacci, na?
Yes.
Any value, if I want to calculate any value in between or whatever value, if any value I want to calculate, Fibonacci of n is Fibonacci of n minus 1 plus Fibonacci of n minus 2. What is my n minus 1 and n minus 2? This is the last two value that I am writing here. N minus 1 I have taken fib n minus 1, n minus 2 I have taken fib n minus 2. Am I writing the same here as my output? And finally, what I want? I want to return it, return the output. So just write return output, fine. So here comes the very important thing that I will discuss it here. So if I, according to you, is everything fine here? And I have written my code properly or not? Tell me. Ruchi, tell me. Mr. Sir, tell me, please. Is everything fine?
Yes.
Fine. Ruchi, you tell me.
Yeah.
Fine. So let's run it. Or let's call the function. So let's call, let's say 4. Write it 4 here. And let's call the function. This star is showing that the program is still running. And what error I am getting? Maximum recursion depth exceeded. This is the error. According to us, we have wrote everything correct, but still I faced an error. So let's understand why I am getting this error and how we can resolve that error. So this is very important thing, and you will enjoy this thing very thoroughly.
Okay, we have not limit this thing now. This will go infinity.
So
That's why feeding the limit.
so we have defined a base case here, n is equal to 1, na? So we have limited it. That's why we have defined a base case here.
Then why it's exceeding the maximum limit?
So that I am going to explain you right now. So that is the thing. I have done this mistake intentionally, so that first I will show this error to you. Thereafter, in the second step, I will explain you why I am getting this error and how we can rectify it. So let's understand first why I am getting this error. So let's take this first thing. What I have done here, I have called this function fib. Fine. So if I am calling this 4, what this 4 is doing? When I am calling this function 4, what it is doing? According to my definition, according to my output, what it is doing? It will, this 4 will call 3. and this will call what? 2. It is the sum of my 4. Fibonacci 4 means what? Sum of the fourth Fibonacci number I want to calculate. Are you getting my point? Fourth Fibonacci number I want to calculate. So that is calling one number before it and one number, 2 number before it. So this Fibonacci 4 is calling this Fibonacci 3 plus this Fibonacci 2. Are you getting this?
Yes.
Ruchi, you?
Yeah.
Now, let's understand this. It will first execute the first leg. Thereafter, it will move to the next leg. See, this thing is coming first. This is coming later.
Yeah.
So first it will complete the execution of this thing. First, it will complete the execution of this part. Fibonacci of n minus 3. Sorry, 4 minus 1 is 3. So it will complete this leg. Thereafter, when this leg get completed, it will go to the next leg, this leg. So let's first come here. Now this 3 will do what? It will call 2, and this will call, and this one. Fine.
Yes.
This, what this 2 will do? 1 and 1. Fine.
Yes.
So see one thing. This 1 will call. When it comes to 2, this 2 will call 1, and this 2 will call 1. Fine. Sorry.
Yes.
Oh, sorry. This is 0, na?
Yes.
Sorry. This is 0. This 2 will call 1, and this will call 0. Fine. Now, this 0 will call minus 1, and it will call minus 2. This will call minus 3. Sorry, minus 3 and minus 2. This will call minus 3 and minus 4. And it will keep on going. This 1, when it comes to this 1, I have given the base case of this, n is equal to 1. So when n is equal to 1, return 1. So it is going to return 1. Fine. But I have not written the base case for this 0. So it will keep on going, and it will go till infinity. Are you getting my point?
Yes. Yes.
And since it is going till infinity, it is not stopping. I am getting this error, maximum depth error. Maximum depth error I am getting. So to rectify this, what I have to do? I have to give 2 base case here, because here 2 base cases required. So I have to write the base case for this 0 also. If we do not write the base case for this 0, it will keep on going and it will never end. And we will finally get an maximum depth error. Have you understood this?
Yes.
Ruchi, you tell me.
Yeah.
No, I'm not the way you are speaking, I'm getting the vibes that you have not understood.
Yeah, I've not understood.
So, okay. So what you
Why
have not,
4 bifurcating and give us 3 and 2? Whereas the sum of 3 plus 2 is not 4, it should be 5.
What this?
This thing I'm not getting. When we bifurcating this 4, it give us 3 and 2. How?
Okay. You are okay, fine. See, here Fibonacci of n, what is it means? This is n is equal to 1. Let's see, this is n is equal to 1, this is n is equal to 2, this is n is equal to 3, this is n is equal to 4, this is n is equal to 6, 7, 8. It goes like that. This thing. Are you getting?
Yeah.
So that n, if I am telling, I am asking this n is equal to 4. That means this 4, not this thing. So this is n. This is not my sum.
Okay.
This is my
Okay.
nth value. To calculate this n, I have to first calculate I have this n3, f3 and this 2. The preceding two value, nth value. Are you getting?
Getting.
And I have to sum these things. But this is the nth. This is the n value. Now tell me, other doubts?
No, fine.
Have you understood now? This
Yes.
4 is telling
Yes.
me to give 3 and this 2. This 3 is telling me to give the 2 and this 1. This 2 is telling me to give me 1 and 0. Now I have the base case for this 1. So this 1 is returning what? I have the base case for this one. N is equal to 1, return 1. This is returning 1 to this thing. But I do not have the base case for this 0. So this 0 is keep on going. Fine.
Fine.
So let's write the base case for to rectify this error. What I have to do? I have to simply write. I'm taking this and I have to simply write what? I have to simply write the so it would be now what it would be better if I write the base case for 2. N is equal, let's see, let me tell you one thing more. So it would be better if I will write let's say 4 gives me 3, it gives me 2, then this gives me this 2 and this gives me 1. Fine. See here, if I take any such number like that, I have the return value for this one. Fine. But I do not have the return value for this 2. This return value of this 2. So what is the return value for this 2?
Return value.
Okay, let me not explain you like this. Let's forget this. So come here. So I have to give me the base case.
Okay.
So if n is equal to 1 or n is equal to 2, my return value should be 1. You understood this? Now see. 1, 1, 2, 3, 5, 8, 13, so on, 21, so on. This is my n is equal to 1. This is my n is equal to 2. This is my n is equal to 3. This is my n is equal to 4. This is my n is equal to 5. This is my n is equal to 6, and so on. When I take this 4, this n is equal to 4.
मैं सोने जा रहा हूँ.
Yes, go for sleep. This 2, this 3, this 2, and this 1. See now, here, let's understand this. This is my nth value, n value, and I'm telling it to give the third value, second value, this. I have the return for this one. This is returning me 1. But this should also return me 1 only, na? My first n is equal to 1 or n is equal to 2. In both cases, what is my return value? 1. In n is equal to 1 or n is equal to 2, in both cases, my return value is 1. So, one cases I have given, when n is equal to 1, I have given the return. But when n is equal to 2, also my return value should be 1 only. In either cases. Fine. If I will give it like that, my cases I will never fall into the infinite loop and I will get the result. Do you understood this?
Yes.
Tell me, Mr. Sir.
Yes, in case we understood, I mean, in case if we would have started from 0, then it had been 0 return value. But since we have started from 1.
Yes, fine. You are right. Since we are starting from the first two,
Because
first one.
because 0 plus 1 is equal to 1.
Yes. In case we have started this with 0, then in that case, we would have returned a different value. You are right. So, let's clear this. And now I have written the base case here. Now I am going to run this. Let's run this. And now let's see. Let's take 4. See. Let's take 5. Now you are getting. Let's take 6. Let's take 7. Fine. I am getting.
Yes.
So, this is all for the day. So, I will upload this lecture tomorrow. And I will also share this sheets with you. So, those of you who are watching this, let me stop sharing first. And let me view this as a gallery. And stopping. So, fine, guys. So, we will, in the next session, we will continue doing the recursion. We will practice few more questions in the recursion. The concept is same, whatever we have done, but I want you to, because this is one of the toughest thing. The first interview when I have faced in coding interview, the question they have asked me is the question from recursion. And I tell you, so but you will not get because let's say if Mr. Sir is going for some interview, definitely you will not face, they will not ask you to code and all those things, because you will get an interview in a very different kind of interview. But let's say if Ruchi, you want to go in this field, maybe they can ask you a question. So that's why it is necessary for you to understand, and I'm covering this topic in a very, very depth, in very depth. If you simply understood this, I can guarantee you, you will crack any coding questions. Any interview you will crack Python. If you simply follow whatever I'm telling, or teaching you here.
Okay.
So, fine. This is those of you who are watching my recorded session. And if you want to join my free live classes, you can join my Instagram group, because there I used to give the regular updates. I even take the doubts, individual doubts of the people, and I resolved that doubts. And so you can go to the description section of the video and join the Telegram link. Also, we used to crack a lot of jokes in between the class to so that we remain focused. So now I'm going to stop the recording. So